So hey, hello everyone, and I welcome you all to Rankplus JEE English. In this video, I'm going to concise the complete chapter of thermodynamics in 30 minutes. What we are going to study is all the topics which are there in JEE 2025. So I have divided these topics into 6 parts. I will be covering each and every topic in detail. But before we going forward, you have to join our Telegram group because there you will get the PDF of these sessions. That is very required if you wanted to quickly revise the whole concept of thermodynamics. So first of all, let's start with the very basic concept. I'm not going to waste your a single minute here. So the first thing which you need to understand is that thermodynamics is basically focusing on a macroscopic level only. Thermodynamics is a macroscopic science. Here we do not deal with the atomic level things. So it's a macroscopic science. And if I'm talking about the data, or we say particularly the variables we have to deal with, there are 5 variables. Because for numericals, these variables are so important, and I can concise this into PV nut. Similar to the kinematics, in kinematics I told you that basically we are dealing with the UV set. UV set means the initial velocity, final velocity, displacement, acceleration and time. In kinematics we have those 5 variables, and in thermodynamics we have these 5 variables. PV nut. What is this PV nut? P stands for the pressure. P is pressure. V is volume, and N is, you can say, mole. Fourth, Q is internal energy, and T is the time. And T is time. So these are 5 variables which we must be knowing, and we have to handle only these 5 variables whenever we are dealing with the numericals related to the thermodynamics in physics. Okay. And there is also some terms like entropy, Gibbs energy that we will use, but those are not very much important for your JEE Mains exams. Okay. So let's begin this thing. First of all, we need to understand that how many systems are there. First of all, we need to understand how many systems are there. So first system is open system. Okay, I think that you must be knowing a basic difference between system and surrounding. Anything under our consideration is known as system, and everything other than the system is our surrounding. Okay, so open system is a system in which the energy can be exchanged, matter can also be exchanged. Take an example, because using these examples it will be a very quick revision for you. Consider a tea. Consider a teacup. I'm considering a red tea, like a red chandan of Pushpa movie. So I'm taking a red tea here, and in this tea you can say that it's open from the end. There is transfer of matter, because we know that there is evaporation happening. The water will evaporate, and this water will evaporate. This is the matter. So matter will go out, right? Similarly, you can add the sugar if you want. This is also a matter. So basically, in this type of system, the exchange of matter is allowed. So you can easily some substances can move out of this system, and some substances can go into the system. And other than that, I can also say that the heat the heat is also being transferred from the system to the surrounding. So there is a heat exchange between the system and surrounding. There is a heat exchange between system and surrounding. Okay. And other than that, there is another system which is known as a closed system. In closed system, energy can be exchanged, but matter cannot be exchanged. This energy can be exchanged, but matter can't be exchanged. We'll be taking the similar example. And in this case, basically we have put a lid on the surface. So due to this lid, the matter can't escape the container. Okay, the matter cannot escape the container. So this is basically a closed system. I hope that this is clear to you. Now there is another system which is known as an isolated system. In the isolated system, basically we say is that nothing can be exchanged, nothing is allowed to move out from the system. It's an isolated system. Energy can't be exchanged, matter can't be exchanged. Okay, that's all. Now, once the system is clear, we must be looking forward for the zeroth law. There is a very nice story around that why this law is known as zeroth law. I'm not going into that story. I'll take that story part when I'll be taking a lengthy lecture on the thermodynamics. So here I'm only stating that what does zeroth law says. So zeroth law is basically a fancy way to tell us about the equilibrium, right? In this, basically we says that if there is a adiabatic wall, what is adiabatic? Adiabatic means it won't allow the exchange of heat. There is a adiabatic wall which I am taking. It will not allow the exchange of heat. That's why I'm keeping this as red. I'm keeping this whole thing as red. Okay, so this is the adiabatic wall. It would not allow the exchange of heat. It would not allow the exchange of heat. Now in this, let me put and this green is basically a diathermal wall. This is a diathermal wall. It allows easy exchange of heat. Easy exchange of heat energy. Okay, now this is my C system, and this is also adiabatic wall. Okay, this is my B system. This is my C system. So it states that after some time, what will happen? After some time, After some time, this A and C will be in equilibrium, will be in thermal equilibrium. What does it mean? It means that the temperature at A will be equals to the temperature at C. Similarly, the temperature at C will be equals to temperature at B. Let me tell you in a simpler way. After some time, the heat will easily be transferred from A to C. There is a easy exchange between A and C, and there is also a easy exchange between B and C. What will happen? That A will be in equilibrium with C and C will be in equilibrium with B. It means that all of these three are in equilibrium. So this zeroth law says that if A is in equilibrium with C, A and C is in thermal equilibrium. When I'm talking about equilibrium, it means thermal equilibrium. And B, C is also in thermal equilibrium. Then I could say that A, B, C all are in equilibrium. A, B, C all are in equilibrium. Or you could say one thing also, that if A is in thermal equilibrium with C and B is in thermal equilibrium with C, then A is also in thermal equilibrium with B. Indirectly, there is no way for the heat exchange, but with when we have a common point, there is a linkage between A and B. Okay, this is basically a fancy way to say that how we attain a thermal equilibrium. Okay, now after that we have the most important law. I'm saying that this is ultimately a law on which there is multiple questions that might come in your JEE exam. So second thing is first law of thermodynamics. First law of thermodynamics, there is slightly difference between what you study in chemistry. Okay, but do not be confused about that. First law of thermodynamics. In law of thermodynamics, it states that delta Q, that means the heat provided, will be equals to delta U plus work done. Plus work done. There are three terms in this. The first one is the heat supplied to the system. Heat supplied to the system will be considered as positive, and this second is the internal energy of the system. And this third is the work done by the system. Okay. And you know what? There are three terms in this first law of thermodynamics. And in each terms, we have a different formula or a different way to get the correct answer. Like if I need to just wanted to calculate that what is the amount of heat. So for the calculation of delta Q, for delta Q calculation, what you need to do is, there are multiple ways to calculate delta Q. The first one is heat capacity. S is equals to delta Q divided by delta T. Heat capacity is equals to delta Q by delta T. You can write that delta Q is equals to S delta T. That is your first case. Similarly, second, specific heat capacity. So you could write specific heat capacity. Specific heat capacity, small s, will be equals to 1 divided by m delta q divided by delta t. You can write it as delta q is equals to ms delta t. Then there is third term, molar heat capacity. For the molar heat capacity, you can write C is equals to 1 by n delta q by delta t. And you could write it as delta q is equals to n c delta t. Now there is further variety for this molar heat capacity at constant pressure and at constant volume. At constant pressure, we have to take Cp. Okay, at constant pressure, we have to take Cp. And at constant volume, we have to take Cv. Okay. Now, these are the ways to calculate. These are the ways to calculate the delta Q. Similarly, for delta Q, delta U is basically the internal energy that is included in, I would say, kinetic energy and the potential energy of all the molecules. For the calculation of work, for calculation of work, we have 4 different processes. There are 4 different processes, and work done due to all those processes are different. The first process is isochoric. In isochoric, we says that the volume is constant. We have constant volume. Okay, for isochoric, we says that we have constant volume. Then there is isobaric. And pressure. There is isothermal and temperature. And the last one, very, very important, I would say. Very, very important. Even for the JEE Advanced, it's very, very important. It's a adiabatic. It's a adiabatic process. And in this adiabatic process, we have heat constant heat. We have constant heat. So these are the main processes which we have to study. I have already shown you in the syllabus, like if in the syllabus we have to see thermal equilibrium, we have discussed the concept of temperature, heat and temperature. Heat is basically the flow of energy, and temperature is basically the measurement of hotness and coldness of the body, right? This is a topic from the thermal properties of matter, and zeroth law is completed. Heat, work, and internal energy. Heat is a form of energy. There are 3 different processes which I showed you, that how we are going to calculate the heat. Heat can be calculated from the heat capacity. It can also be calculated from the specific heat capacity. It can also be calculated from the molar heat capacity, right? Then similar there, for the work, we have 4 different processes, and we have to see that. And basically we need to learn in this thermodynamics. The whole chapter is basically going around the first law of thermodynamics. This is the most important thing, and you must know that how you are going to apply the law in various types of numericals. So in the syllabus, we are only seeing that the process which they have mentioned is the isothermal and the adiabatic process, right? So we are missing something. As I told you that there are four different processes: isothermal, adiabatic, then there is isochoric, isobaric. So isochoric and isobaric is missing from this. But if you see the NCRT, you will find it. And even in the like question paper, you might get the questions from there, right? So we have to do that. Then the last portion is the second law of thermodynamics. It basically tells us about the randomness, that whether this reaction is reversible or not, and is this reaction is spontaneous or not. So we have to calculate the Gibbs energy, and according to that Gibbs energy, we can ultimately comes to the conclusion that yes, this reaction is feasible or this reaction is not feasible. Okay, so these are the only topics which we have to cover. Let me briefly concising all those methods to get the calculation of work done, right? So this is what we have to learn. Let me take this chart in. Let me take this chart on another page, concise it. Okay, now see, for this isochoric work done, and you have to imagine something. Like without imagination, there is nothing in physics. You have to imagine that there is one. So I'm considering that there is one system like this. There is a piston out there, and there are so many atoms here. Okay, so this is basically a cylinder, and this cylinder is having a height of h. Cylinder is having a height of h. There is area of base is a, and here we are providing some fuel. We are providing some heat. Heat is delta Q. Okay, and when we are providing the heat to this system, what will happen? These molecules will gain some internal energy. There will be a change in the kinetic energy and the potential energy of all the molecules in this system, and due to that, it might happen that there will be a rise in the pressure. There will be a rise in the pressure, there will be a rise in the temperature, and it might happen that this lid or the piston can move further, and if this piston moves, there will be a work done by the system. I hope that this is clear. And it might also happen that this system, there is less pressure out there, and due to which this piston can move further downward, due to which I would be saying that the work is done on the system, right? So now we know that work done is equals to F dot ds, right? Work done is equals to F dot ds, and pressure equals to force divided by area. So I can replace this force with pressure into area, and area dot ds is actually the change in the volume. So you could say that work done is actually equals to P delta V. Work done is equals to P delta V. And if I'm seeing any integration, I have in my mind that I have to integrate, because integration means that we have to get the area under curve. So if there is PV curve, if there is PV curve, and if I'm getting the area under this curve, if there is PV curve and I'm getting the area under PV curve, this will give me the work done. This will give me work done. Okay, this will give me the work done. I hope that this thing is clear. Now, this, once we are done with this example, you can easily find out that what is the work done due to this. As we know that delta V is equals to 0. And if delta V is equals to 0, work done is P delta V. That means work done is 0 because there is no change in the volume. And in isobaric system, we can easily find out that work done is equals to P delta V because pressure is constant. Only you need to find out is what is the change in the volume. Similarly, if I'll use the ideal gas equation in it, I can put further that this is also can be written nR delta T. I hope that this thing is clear to you, right? Now, in the isothermal process, work done can be find out using nRT ln V2 divided by V1. So this is the formula which we can get, right? Say, any doubt regarding this? Okay. There are comments coming. Hello, Rathi, Gada Ladka. Hello. Rahul. It's basically I have to concise it, so I cannot crack the joke in the lectures where I have to be very concise, right? So it would be boring, and you know that these boring lectures will give you the result, because the most important thing for me is to get the result out of you, right? So either you want the result or you want the entertainment. You tell me, what do you want? You want the result or you want the entertainment? If you want the entertainment, I will entertain you, right? But if you want the result, I will give you the result. That is why I'm taking these classes, right? So now, it's time for the adiabatic process. Adiabatic means there is constant heat. There are different forms which are coming again and again, and they are just checking that whether you know about the conditions or not. Okay, so the first conditions in the adiabatic is that PV gamma is equals to constant, and this gamma is actually a ratio of Cp divided by Cv. This gamma is actually a ratio of Cp divided by Cv, and this Cp minus Cv is equals to R. This is the Mayer equation, right? This is the Mayer equation. And PV gamma is equals to constant. This is very, very important. This is written in the NCRT. But if you see the JEE previous year questions, you will find there are so many variation of this simple equation. Basically, if I'll use the ideal gas equation, I can get another relationship that T V gamma minus 1 is equals to constant. So this is also a very, very important equation which you need to know. Okay, then again there is one equation. The third one is that if I need to take pressure also, so I can write this as P 1 minus gamma, T 1 minus gamma, and T you can put here T gamma is equals to constant. So these are very, very important conditions which you must remember in case of adiabatic. Okay, and the work done due to the adiabatic is very, very simple. NR T1 minus T2 and NR T1 minus T2 gamma minus 1. So this is the formula for getting the work done in case of the adiabatic process. And other than that, what you need to know is the graph. That if you are seeing a graph, can you identify that which graph is for a isobaric process or a adiabatic process, isothermal process? So I'm considering here PV graph. Okay, now let me first draw this thing. This graph is for, tell me, isobaric. Now this graph is for isochoric. This graph is for isothermal. And this graph is for adiabatic. Okay, these graphs are very, very important. And other than these graphs, you know that when you are finding the work done, it can be done using the area under curve. Okay, I hope that this thing is clear to you. Is this thing clear? Neeraj. Okay, Neeraj, you want me to explain it from the starting. Basically, once I'm here to concise each and everything in the thermodynamics chapter. So there are the subject, the syllabus is divided into 6 different subtopics. I have started with the very basic definitions regarding, if you haven't subscribed our YouTube channel, subscribe it. And if you haven't followed us on the Telegram, please follow us on the Telegram as well. So we have till discussed that thermodynamics is basically the macroscopic science where we have to deal with the data. These are the data which we must be well aware with. PV nut, the pressure, volume, the mole, the internal energy, and the temperature. Then I discussed that there are 3 types of system. The first one is the open system, in which energy and the matter both can be transferred, both can be easily be exchanged. Then the second one is the closed system. In the closed system, when I'm talking about the closed system, energy can be exchanged but matter cannot be exchanged. In the isolated system, energy and matter both can be exchanged. The second one is the zeroth law. It is basically a fancy way to say that if one object is in thermal equilibrium with the another object, and the another object is in thermal equilibrium with another object, and there is one common object between them, then all of them will be in thermal equilibrium. This is the law regarding the thermal equilibrium, and it also states about the temperature. Then the most important and the superhero of this chapter is basically the first law of thermodynamics. It is based on the conservation of energy. This law is based on conservation of energy. And if you know this law, you do not need to be tensed about that whether you will be able to score well in thermodynamics or not. So this is our first law of thermodynamics. It states that if we are providing a heat, some amount of heat will be like absorbed by the system to increase the internal energy of the system, and some of the heat will be converted into the work. Okay, for the delta Q, that means the heat calculation, these are the processes which we are going to follow. And for the calculation of work, these are the processes, 4 processes. And I have concise whole process here. What are the formulas you need to remember, and these are the graphs which you must remember. So this is not temperature. What? I have written the time here. Oh yeah, my mistake. This is basically a temperature. Yeah, my mistake. So these are basically the variables of the thermodynamics. Okay, so this is all in this chapter. I'll be coming again back with another chapter, and I'll be concising all the topics written in the JEE syllabus within 30 seconds. And these are very, very important series for you. Please like this session and subscribe the channel if you haven't, and share this with your friends. Okay, till then, bye bye.